A equals 11, solve for C. We know this is a 45, 45, 90 triangle because there is a right angle. So that tells you it's a right triangle. And then the other angle is 45. Therefore, the other one is also 45. So they're giving you A, they're giving you this leg here, and they want you to solve for C. And that reference triangle is just so critical here. X, X, X root 2. They're giving you the value of X. So what would the value of C be?
So this would be solving for the hypotenuse, right?
It is, yeah. It is, yeah. And you've already got the leg, and the legs are the same. You know, these values are really the same.
Oh, so you're just going to double the short leg?
That's for 30, 60, 90. This is a 45, 45, 90.
Yeah.
So what is this right here off to the side here of the X? What am I pointing at here?
X square root 2.
X square root 2. So you take whatever the leg is, like it could be written this way, leg square root 2. Because that's the leg and that's the leg. You take the value of the leg and you multiply it by the square root of 2. And that's it. That's your answer. All right, so let's look at another problem here, like this one. And what's interesting, or what's important, I guess, for you to recognize is that there's other ways that you might see a 45, 45, 90 triangle. Like this is also a 45, 45, 90 triangle. And you might say, well, hey, Matthew, I don't see the 45s, I see the 90. Yeah, but if the legs are the same, that means the angles are the same. If the angles are the same, then they have to both add up to 90. And if they're the same, the only possibility is if they're 45.
Okay.
So just identification, you know, I don't know if you're into like, you know, if you like dogs or trees or, you know, cactus or whatever, like it's always cool when you like are somewhere and someone's like, what's that? And you're like, oh, it's a prickly pear cactus, or that's a, you know, a certain variation of dog that, and that's what's going on here. It's like, can you identify what that is? Can you just see it and be like, oh yeah, that's it. So again, they're giving you the leg and they want the hypotenuse.
Oh, okay. So is it just the same thing, the
Yes.
legs root 2?
Yes.
Okay.
Yes. So 7 square root 2 is the leg.
Okay.
All right, so let's look at another problem here. So what are some other possible variations on the same problem? So again here, this is a 45, 45, 90 triangle. Can you tell me why it's a 45, 45, 90 triangle?
Because there's a 90-degree angle, and then also both of the legs are equal.
How do you know that these legs are equal? What is it about the picture that's pre-drawn digitally that you know about that?
And
it's right here. What does this mean? If you remember.
That they're equal.
That they're equal. Yeah, the angles are equal. And if they're equal, then they have to be the same. The only way they're the same is if they're 45 and 45, because that adds up to 90.
Mm-hmm.
So this time V which is the leg. And by the way, see how the triangle's oriented differently? I mean, that doesn't matter either, but it's just a variation on the same thing. This is 11 square root 2. The leg is 11 square root 2. The hypotenuse is the leg times the square root of 2. So instead of the leg, what are you gonna put into this position instead of the word leg?
11 square root 2.
Yes. And so the square root of 2 times the square root of 2 is?
The square root of 4, which reduces to 2.
So it's 11 times 2, which equals 22. Okay, let me have you try one on your own. And again, this is no different than the problems we've been doing. It's just different numbers and different letters. Same process though.
Okay.
So give that a try, please.
For H, I got 18.
Yes, H is 18, perfect. Any questions on that sort of style of problem where they give you the leg, then you have to find the hypotenuse?
No.
Okay, we're gonna go in the other direction now. So now I'm gonna give you the hypotenuse and you're gonna find the legs.
Okay.
So in some ways you might even say, well, this seems easier when you see the problem here worked out for you. So this time they're giving you the hypotenuse. The hypotenuse is 2 square root 2. And if we go to the reference triangle, x root 2, you set the known side, which in this case is 2 root 2, equal to the reference side, which is x root 2, and then you solve for x. Can you visually tell me the value of x just looking at it? Like, do you see that they both have a root 2? And so x is just the value that's in front of the root.
Oh, so it's just 2?
It's just 2, but that only works like if it's root 2. If this were root 8, you would not do that. So the more general approach, the one that always works, is to divide both sides by root 2. Those cancel and x is 2. what does X represent in this problem? What's the word we would use for X to describe this triangle?
X is the legs.
The legs, right? So we just found the leg. What do they want in the problem here? They want B, which is the
Leg.
leg. So it's a lot of like translation. You know, it's like B is a pronoun, you know, like someone could refer to you as her or she, or they could refer to you by your name, Julia, right?
Hmm.
And in the context, you're supposed to realize like what you're referring to here. So sometimes you gotta be able to map. Okay, they want B. B is the leg. Leg is really X.
Okay.
It's not written here, but what is A? What is the value of A over here?
It's equal to B.
It is equal to B, and what is B equal to?
A.
Yeah, yes. Okay, what
Oh.
numerical value is it equal to? I like your literalness. You're like, yeah, it's A is B and B is A. Because you're not wrong. You're right. It's just that it's also two, because it's
Yeah.
also a leg. The legs are the same. You have two legs. They're the same length. I know there's conditions where they're not, but in this situation, the legs are the same in this triangle. That's what makes it special.
Okay.
All right, let's try another one here. So if you understood that, and I think you did, I want you to try this one on your own, please. It's exact same problem, meaning same process, just different numbers, different letters, kind of. Actually, I think it's the same letters, but go ahead and work that out for me, please.
Is B 9?
Yes, B is 9. What is the value of A?
9 as well.
9 as well. Okay, good. Now, the as you know, it just gets a little bit more difficult when it comes to, you know, the next type of problem I'm going to give you. Let's try this one. This is and just quickly check in here. Is this path that we're going on of working on these types of problems, is this helpful for you?
Yeah.
Great. Okay, so this time they're giving you C, just like we did in the last few problems, but there's no root next to it. So like I mentioned, that reference triangle really comes, you know, into play here. So C is 8. So you set your known side 8 equal to your reference side. And since there's no root, you can't just say that X is, well, whatever it is. So the more general approach is what you try. And the more general approach is I'm going to divide both sides by √2. From previous lessons, do you recall how we reduce this, how to simplify what's on the left?
You multiply by the square root of 2.
On the top and the bottom.
Yes.
Okay. Can you reduce that for me?
It is 8 square root 2 over 2.
Yes. And what does that reduce to?
That reduces to 4 square root 2 over 1.
Yes. So 4 square root 2 is x. And x is the reference triangle, but what's the word that we would use to describe x? How would we describe that in terms of the triangle?
How to describe x?
Like what? Yeah, I'm asking you to. Okay, sorry. I'm just asking you to say that it's the leg. I'm trying to build this connection that x is the leg. X is the leg, and like, there's nothing because I want you to really. Maybe this feels complicated. I want you to cut through all that and realize, okay, it's just x is the leg, a is the leg. Once I know x, I know a.
Yeah. Okay.
So what is the value of a in this problem?
A is 4 square root 2.
And what is b?
4 square root 2.
Perfect. Okay. Let's try another one here. Actually, I'll have you do this one on your own. Give that a try, please.
For A, I got 10 square root 2.
Yes, a is 10 square root 2. And what about b?
B is 10 square root 2.
Good. Okay. So the next style of problem that you might see, and what's nice is that we can go through all the like variations on the same problem so that you can really get a sense that like they're all the same. You just do the same thing over and over again. Again, this time they're giving you the hypotenuse. It's called W. They want you to find the leg. So you set the known side, 13 square root 98, equal to x root 2, because x root 2 is the hypotenuse of the reference triangle. So I know maybe that word isn't meaning much to you, and I'll just give you a brief short history. Right now, when you have a question about anything in the world, you either go to Google or probably YouTube. I'm guessing. Maybe you do a few other things like social media or ask parents or friends, but we tend to like go out and like ask the question. Like I was looking about how to get a stain out of something the other day, and it's exactly that's what I do. There used to be reference books, handbooks, and guides that were printed materials, and
Mhm.
that's why I keep calling it reference, because that's it. It doesn't make sense to say internet, but we treat the internet like it is a reference. But that's what this is meant to be. It's like the standard or the thing that always works. And that's why I keep calling it a reference, because it's like the thing you're going to go look for to help you solve this. So to solve for x, you divide both sides by root 2. We've done that a number of times now. This time, though, you have two roots, and they're not the same. So if you recall, square root of a over the square root of b is the square root of a divided by b. So this is 13 square root 98 divided by 2. What is square root 98 divided by 2? It is 49. Is that a known value? Yes.
Yes, it's
It's
7.
7. So this is 13 times 7, which ends up being 91. What is the value of u in this problem if v is 91?
If V is 91, U
Yep,
is 91.
it is also 91. Perfect. Do you feel like you understood that? The only difference, I mean, you're still dividing by square root, but this time you just have to handle the numerics of it.
Yeah.
Okay. All right. Okay, let's have you try this. Ooh. So I'm going to just change this one slightly because I don't want to get into this quite yet. Okay, so W this time, we're just going to make this 8 square root 50. And I want you to try this one, please.
For V, I got 40.
Yes, V is 40. And what would the other leg be?
40.
40, perfect. Excellent. So what are some other possible types of problems that you might see? So this is we're pretty close to getting into like the level of difficulty that you might see on a standardized test. So this problem, again, they give you the hypotenuse. And sometimes it's better to even just like say that, and like, I don't know if you, when you read a problem, you'd like almost have a conversation, it's almost better to say, if the hypotenuse is 8 square root 6, what is the value of the leg? Like, that's the way I want you to read this, because that the letters are not important. And so this time you said 8 square root 6 equal to x root 2. When you divide both sides by root 2, again, this part you can reduce. It becomes 8 square root 6 divided by 2, which is 8 root 3. And this is your answer. And so the other leg here is 8 root 3. So sometimes this root doesn't actually reduce.
Okay.
So what we've seen so far is we've seen problems where the root 2 goes away completely. We've seen it where it becomes a number and you multiply. Now we're just seeing it where it's just a root. And that's okay.
Okay.
So if you got that one down, sorry, I'm a little lag there on my machine. Will you please try this problem here for me? And again, like just you're solving for the leg. Think of this as just leg and leg.
Okay. Um, 15 root 13.
Yes, 15 root 13 and 15 root 13. Perfect. Okay. So the last kind of problem that you might see is one, and I guess we'll just talk about this first just to see where you're at on it. Do you know how to reduce the square root of 120?
Is this where you do the like factor trees?
Yeah, I call it a factor tree. It may not be called that, but yes. And you start with prime numbers 2, 3, and 5, and so on. So this would be like 2 and 60, 2 and 30, 2 and 15, 3 and 5. And do you recall what to do from this point forward? Do you remember how you decide what stays inside the root and what comes outside the root?
I think, let's see, you group together. Oh, okay. So, all the twos would be together, so that would be grouped.
You look for a pair. I like the word pair, but you could choose another word. But because it's a square root, that's why you look for a pair. So this extra 2, it's like a sock that you don't have the other sock for. Same with the 3 and the 5. They're like the socks that don't have a, what's the right word? They don't have a partner. So you bring a 2 out, and it's the square root of whatever it's left over, which is the 2, the 3, and the 5 there.
Mhm. Oh, okay.
Which is 2 root 30. So you might wonder why we're going into this diversion on reducing roots, which I do have another worksheet I'll send to you because it's a good skill to be able to do. It comes up quite a bit. This problem here, again, they're giving you the hypotenuse, they want the leg. So you said 5 square root 80 equal to x root 2, you divide by root 2. And like we've done now, it's 5 square root 40 because the 80 divided by 2 is 40. But this is not the final answer because this right here you have to reduce. So I'd like you to try reducing the square root of 40 for me, please.
Is it 2 root 10?
Yes, the square root of 40 is 2 root 10, but there's this 5 that comes along with it. So what does that do? You have to keep multiplying. So like whatever the square root of 40 is, you multiply times 5, but the 5 only affects the number on the outside. So it's 10 root 10. Is that okay?
Yeah.
Okay, so just to see if that's kind of dialed in, what is 7 square root 28? Could you just reduce that for me, please?
Fourteen root 7.
Yeah, 14 root 7, because you bring a 2 out, 2 multiplies the 14. That's awesome. That is really, really good. Okay. All right. So you got that down, and that kind of, we should do one more of these. We'll work it out together though. So actually, this one's very different than the others. So let me actually not do that. Okay, let's look at 30, 60, 90 triangles. So we like it's in your thinking, like you almost have to, and you're a swimmer, right? Is that what I recall?
Yeah.
So you know, like there's probably 2 swimming strokes that are like kind of in the same broad category, but they're individually, very different. And what would that be in swimming? Could you have an example of like two different strokes, but one is, obviously you can't do it. They're not the same. Like if you're in a blank stroke race, you have to do it one way, and then.
So 2 strokes that are like very different.
Well, yeah, but like I'm trying to think of something where it's not like a back versus a front stroke. The butterfly is not the same as a breaststroke. Is that true?
Yeah. Okay.
But they're kind of the same in some ways, right? They're both you're on your stomach swimming. Is that right?
Yeah.
And that's kind of what I'm trying to get across here is like we just went down that road, and now we're going down this road. And while there's similarities, you have to be very disjointed in your thinking.
Okay.
So like, don't feel like it's like, on the one hand, don't, you know some things, but on the other, it's like, you really don't know. You really can't reuse the stuff you've been doing on there.
Okay.
Okay, so here's a 30, 60, 90 triangle. And kind of like the last problems that we did, we're going to talk about why this is a 30, 60, 90 triangle. Well, there's a 90 degree, there's a 30, which means that this one is 60. The short leg is always across from the 30. The long leg is always across from the 60. And that's that whole identification thing. Like I bet if you went to a swimming event and you saw the swimmers, you would immediately know what they were doing, which type of stroke.
Mm-hmm.
And that's what you got to be able to hear. You'd be like, oh yeah, there's the 30, that's the short leg. Okay. Or that's the 60, so that's the long leg. The reference triangle, the short leg is always X. And this is where you double X to get the hypotenuse. And the long leg is X root 3. And again, sometimes the words are easier. Like you take the short leg and you double it to get the hypotenuse. You take the short leg and multiply by the square root of 3 to get the long leg. Now let me just copy this problem again, because we got a lot of words there that may or may not interfere with your understanding. So they're giving you the short leg. You should immediately find C. What is the value of C? How do you find the hypotenuse from the short leg?
Do you double the short leg?
Yes, multiply by 2. So C is equal to 6. To go from the short leg to the long leg, you multiply by the square root of 3. So what is the value of B? It's 3 times the square root of 3.
Okay.
Let's try another one. So the value of A is 5 and they want B and C. But the way that you could read this is if you say, oh yeah, A is the short leg. If the short leg is 5, solve for the hypotenuse, because you can do it in any order you want, and the long leg. So if A is 5, the short leg, because it's across from the 30, what is the hypotenuse? What's the value of C?
The long leg is 5 square root 3 and C is 10.
Perfect. Perfect. Now, I haven't done this in a while, but let's do it for this problem. So A squared plus B squared equals C squared. That's the Pythagorean theorem. This holds true, and we're going to see why it holds true, but we don't want to do it this way because this ends up being, pretty slow. So 5 squared is 25. 10 squared is 100. So sometimes it helps to know that, well, this value right here must be 75. Well, how does this thing inside the parentheses become 75? Well, you square the 5, and then you square the square root of 3. So when you square 5, that's 75. the square root of 3 squared undoes the square root times, I'm sorry, 5 squared is 2, not 25, not 75. When you square the square root of 3, it becomes 3, and that's how you get the 75 there.
Okay.
So it does work. Generally, you don't want to check on these standardized tests because it takes too long. The better trajectory is to try and, go through it like we've been doing, just solve. All right, let's try. All right, let's try another problem here. This time I'm going to give you the hypotenuse to start. So this time I'm giving you C. C is the hypotenuse. The best trajectory is to find the short leg and then the long leg. Could you try that for me, please?
So to go from the hypotenuse to like short leg, would you divide by 2?
Divide by 2, yes.
Okay, so A, the short leg is 6, and then
Yes,
the long leg is 6 square root 3.
perfect. Perfect. And again, 6 squared plus 6 squared 3 squared equals 12 squared. So 36 plus 36 times 3 is 108. And then 12 squared is 144. 36 plus 108 is 144. So these do work. All right, so a good lesson today. I'm going to send you in the email a link to a reducing roots worksheet. It kind of works really hand in hand with the triangles worksheet. So if you've got some time, I'd try working on those again. And we'll just keep going next week on this stuff. I think I'm gonna switch to just doing a few more worksheets because I think that'll really help you build your skills for the exams. And
Okay.
then we'll get back to actually working on some test prep questions. So thank you so much. Hope you're enjoying this and getting some, some math, getting some new math knowledge out of it.
Yeah, thank you so much.
You're welcome. I will see you next week. I guess I should ask you now, is same time, Tuesday and Thursday good for you at 1 p.m.?
Yes, it should be.
Excellent. All right. Thank you, Julia. Hope you have a nice weekend and a good holiday.
Okay, thank you. You
You're
too.
welcome. Bye now.
Bye.